Okay, so in this lesson, we're going to look at what it means to have an exponent that looks like a fraction. And so this is a rational expression. So in the past, remember in previous lessons, we had something that looked like this, and I'm gonna use a very simple example. So we know that 9 squared, this is 9 squared. We know that 9 squared, and notice that the exponent here is a whole number. And 9 squared, remember, means 9 times 9, which is 81. All right, so we know what that means. But what is what is 9 to the 1 half equal to? So that's the question. So what is 9 to the 1 half equal to? So that's a little bit different idea in the sense that this right here is a whole number, and this right here is a fractional expression. So you got to rethink something a little bit here. And so that's what we're going to talk about in this lesson. What does it mean to have an exponent that's 1 divided by n, where n, where n is greater than or equal to 2. So n is a number that could be 2, 3, 4, 5, or something like that. So n is an integer. Remember, make sure n is an integer greater than or equal to 2. Okay? So that's what we're going to look at today. So today we're going to look at expressions like this. So we're going to look at things like rewriting 3 to the 1/5 power, rewriting rewriting x to the 2/3 power, looking at negative 16 to the 1/2 power, things like that. So that's going to be our intent for today. Okay. All right. Now, so let's look at this idea before we really understand what this is. Let's look at this concept. So suppose that x equals 5 to the 1/3 power. All right, suppose that x equals 5 to the 1/3 power. And what I'm going to do with this equation, and you got to listen carefully to this, what I'm going to do to this equation, since this denominator is a 3, I'm going to use 3 in my words. So since this denominator is a 3, what I'm going to do is I'm going to raise, let me go ahead and rewrite this over, I'm going to raise both sides to the 3rd power. So if this was 1 divided by 4, I'd raise both sides to the 4th power. And there's a reason I'm doing this. But I'm going to raise it to the 3rd power. So remember, what I do to one side, though, I have to do to the other. Okay? And before I go any further, let's review rules for exponents from a previous course. So these, remember, our rules for exponents, and these are some of them. So our rules for exponents. All right. So 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 the first one is going to be called the product rule. So number 1, the product rule. And so remember, the product rule says if you have a to the m power times a to the n power, so when you multiply like bases, remember the phrase, when you multiply like bases, you add exponents, that becomes a to the m plus n. So for example, if you have x to the 4th power times x to the 5th power, when you multiply like bases, you add exponents, that becomes x to the 9th power. Okay? And the second one that you learned about was the power rule for exponents. The power rule for exponents. And so the power rule said this, though. The power rule said if you have a to the m power and all of that is being raised to the n power, then you can simplify this by multiplying the exponents together. So this becomes the base, which is a, raised to the product m times n. All right, so that's the power rule. So basically, if you want to look at an example, you could say this. You could say, all right, if I have x to the 3rd power and that's being raised to the 4th power, then according to the power rule, then all I need to do is multiply the exponents together. So 3 times 4 is 12. So that becomes x to the 12th power. Okay? So remember, that's x to the 3 times 4. All right, so which is 12. But remember, though, and when you did this last semester, remember what this out of 4 means. So this out of 4 means I take x cubed and I multiply it by itself 4 times. So recall x to the third times x to the third times x to the third times x to the third. And I'm going to use the product rule with this. When you multiply bases, add exponents. 3 plus 3 plus 3 plus 3 is 12. So you get x to the 12. All right, so this is so rather than see if this was 40, you wouldn't want to write this out 40 times, right? So you want to use the idea that that power rule. So you just multiply exponents together. And there are some other rules for exponents, and we'll get to this through the lesson, but these are the only two I wanted to remind you about for right now. So let's go back to this right now. So we know that the power rule says that when I have an exponent raised to an exponent, I can multiply those together. So 1/3 times 3, so 1/3 times 3 is 5, right? So 1/3 times 3 is 5. So I'm sorry, 1/3 times 3 is 1, so 5 to the first power, let me put that, 5 to the first power is 5. So I get x cubed is equal to 5, okay? All right, now, okay, so we have x cubed is equal to 5, and let's talk about how we can figure out what x is. So remember, since x cubed is equal to 5, since x cubed is equal to 5, x is the number, x is the number whose cube is 5, right? So x is the number whose cube is 5. So whatever x is and I cube it, I'm going to get 5. So that's what that says. So x is a number whose cube is 5. Or I can write it like this. I can write it as x equals the cube root of 5. So that's what that is. So x equals the cube root of 5. Because remember, going back over here, 9 squared means 9 times 9, right? And that's 81. So do y'all agree? Do y'all agree that if I say x is this, and I multiply this by itself 3 times because I'm cubing it, the cube root of 5 times the cube root of 5 times the cube root of 5. And remember, one of our lessons we learned about the fact that if the indices are the same, then you can write this as one radical. So that becomes a cube root of 5 times 5 times 5 is 125. And what times itself 3 times is 125, and the answer is 5. Okay, so notice that's the same. So x cubed is 5. So x is the number whose cube is 5. And so what that means then is that x has to be the cube root of 5. So that's what x would have to be, the cube root of 5. Okay, so notice though, see this right here? So I'm going to rewrite this over. So also note that x is the cube root of 5. But when I went over here, notice that x was also written as 5 to the 1/3. See that? So x is 5 to the 1/3. So which equals also 5 to the 1/3. And so from here, I want you to see what we mean by a to the 1 divided by n. So 5 to the 1 divided by 3, this 3 right here, see this denominator 3? That is your index. Listen carefully. The denominator 3 happens to be the index. And you may say, well, where's the 1? Okay, so we're going to learn about this a little bit better in the next section. But see this 1 here? That's going to be 5 to the first power right here. And so 5 to the first is still 5. Okay? So notice though, the important thing from this lesson is that this denominator is your index. So let's go and talk about this now. So this is going to be the definition. All right, so definition of a to the 1 divided by n. So the definition of a to the 1 divided by n. So if n is a positive integer greater than 1, greater than 1, so meaning n is greater than or equal to 2. So 2 or bigger. So greater than 1 means 2 or bigger. So that's why you see n is greater than or equal to 2. So if n is a positive integer greater than 1 and the nth root of a is a real number, then, all right, so then a to the 1 divided by n is equal to the nth root of a. All right, so real quick, let's rewrite each of the following. Rewrite number 1. 4 to the 1/3. So 4 to the 1/3 means what? Means to, see, this is 3, so that'll be your index, so it means the cube root of 4. Y'all agree? Number 2, x to the 1/5. Well, x to the 1/5 means, see the 5, so it'll be the 5th root of x. 3, let's say 8 to the 1/5. So 8 to the 1/5, the index is 5, right? So it means the 5th root of 8, and so on. All right? So you see what that means, right? So a to the fractional power, in this case, though, the numerator is 1. If the numerator is not 1, that's going to be something else. We're going to talk about that in the next lesson. But if the numerator is 1, 1 divided by n, 1 divided by 3 means cube root. 1 divided by 5 means 5th root. 1 divided by 5 means 5th root. 1 divided by 6, x to the 1/6 means 6th root. So that's important you see that. All right, so that's what this is. That's what that is. Okay? All right, now, okay, so now you should understand this a little bit better, what it means to have the exponent being 1 divided by n. So you can always write it as a radical. So you're going to rewrite as a radical. Okay, so rewrite as a radical. All right, now the directions in the problems we're about to do, we're going to go from a rational exponent to a radical, and then we'll go from a radical to a rational exponent. So you got to be able to look at it in both directions. Okay? Okay, so let's look at the first one. So the first one says this: write the expression as a radical and simplify if possible. So sometimes you'll see the directions written like this. Now here's our problem, and listen carefully. This is going to be 100 to the 1/2. All right, so based on our rule, so you see where I have this rational exponent, you can always rewrite, remember, you can always rewrite as a radical. So write as a radical, that's what the direction says. So you can always rewrite a rational exponent as a radical. So remember, the denominator is your index. Now notice this is 1 divided by 2, so just keep in mind that's the 1 up here in the numerator. So that's going to be the square root of 100. And then it says simplify. So I wrote as a radical. And then I'm going to simplify if possible. Can I simplify the square root of 100? Yes, because the square root of 100 is 10. 100 is a perfect square. So the answer is 10. All right. So I wrote as a radical. So this is your radical. And then I simplified. Okay. All right. Number 2. Let's go to number 2. Okay, so number 2 says evaluate the expression. Now here's the expression I want to evaluate. So you see the directions. Directions can be written in different ways. Okay, so sometimes the directions will just say evaluate the expression. So here's the expression. In parentheses, I have negative 27 raised to the 1/3. So notice I have my rational exponent, 1 divided by 3, and I know that I know the rule. I know the definition about a to the 1 divided by n, so n is your index. So that becomes the nth root of your base, which is a, okay? And so then this means the cube root, see 3, cube root of, and your base is negative 27. All right, so there's my radical, so I rewrote it. All right, now I want to evaluate this. So evaluate means simplify as well. So I got to figure out what that is. So what times itself 3 times? 3 times is negative 27. Well, the answer is negative 3, because negative 3 times negative 3 times negative 3 is negative 27. Okay, so remember what that means, because negative 3 times negative 3 times negative 3 equals radicand, which is negative 27. All right, so that's number 2. Sometimes the directions will just say simplify. And so I want you to look at this for a moment. I want you to look at negative 9 to the 1/2 power. Now, this is where some students get confused with this. So I will remind you, so this is a review from a previous course. Review from a previous course. Do y'all agree? Do y'all agree that if I have, let's say, um, negative 3 squared versus negative 3 squared like this? So in a previous course, you learned about, well, what do I do if the base is negative, like this is here, because that's being squared, and what does this mean here? So in this particular case, what is the base? I know the base here is negative 3 because it's in parentheses, but what is the base over here? So I want you to notice the base here is 3 only. That's what this is. And then in the front, you have this negative. So when I look at this one, this here means negative 3 times negative 3, which is a positive 9. So that's the answer for that one. Here, remember, if there's no parentheses, if there's a negative out in front, the base is only this 3 right here. So when I look at this, and sometimes you may need to cover information up, so when you look at this part here, cover the negative up, and remember this means 3 times 3, which is 9, but there's a negative out there. So the answer here is negative 9. All right? So that's something you learned in previous courses. So now what I'm going to ask you then is this. What is the base over here now? Is the base a negative 9 or is the base only 9? Okay, good. The base is only 9. So what you have to do here is this. So just like we did, let's go ahead and cover up that negative for right now. And let's change this to radical. So I have a rational exponent, we'll change it to radical, so this becomes the square root of 9. But there's a negative out in front. Okay, so notice, cover it up, square root of 9, now put the negative. And we know the square root of 9 is 3, so this becomes a negative 3. So that's the answer. All right? Okay, now let's look at the next one. Okay, so in number 4, we want to evaluate the expression, and then it says if possible. So let's look at this one. This is going to be, I'm going to write this as letter A. So we have, let's say, negative 9 to the 1/2 power. Now remember a while ago, in number 3, we had negative 9 to 1/2 power, but you didn't see parentheses like you see here. Okay? So remember we talked about here. So when we had something like negative 3 to the 2nd power, that the base is negative 3 that's in parentheses. So negative 3 times negative 3 is a positive 9. Okay? So here, the base is negative 9. So I can go directly and rewrite this as a radical. So it becomes, the index is 2, so it means square root. So square root of negative 9. And then remember, there is no number times itself that's a negative 9. No real number times itself that's a negative 9. So remember, the square root of negative 9, we're going to say is not a real number. So that's not possible. It's not a real number. Okay? And in fact, if you use your calculator, just to show you what you would get, so if you use your calculator, so the square root is right here. So second square root, negative 9, notice you get an error. All right, so now don't put the word error here. You got to say it's not a real number. So you remember the calculator says error, but you're going to put not a real number. Okay, B. So in B, let's suppose we had this. Suppose we had 64 to the 1/3. 64 to the 1/3. All right, so I have this rational exponent. I can change it to a radical. So it becomes the cube root of 64. And so simplify and evaluate means simplify if possible. So what times itself 3 times is 64? Well, the answer is 4, right? Because 4 times 4 times 4 is 64. So the answer is 4. Okay, C, you have 9 divided by 121 raised to the 1/2 power. So 9 divided by 121 raised to the 1/2 power. So in previous lessons, you learned some ideas that we're going to use here. But notice the first thing you want to do is change this to radical. So the rational exponent of 1/2 means square root. So this becomes the square root of 9 divided by 121. And then remember, you use the quotient rule for radicals. And so I can rewrite this as the square root of 9 divided by the square root of 121. And the square root of 9 is 3, and the square root of 121 is 11. So the answer is 3 divided by 11. All right. But remember, what's happening here is you're going from a rational exponent to a radical. So you're changing it to a radical. Okay. All right. D. Let's suppose in D we had, and I think I've already done that one, but let's do something like this then. So this is D. Let's say we had 49 to the 1/2 power. All right, so 49 to the 1/2 power, if I change it to a radical, that's going to be the square root of 49, which is 7, because 7 times 7 is 49. E, let's suppose you had negative 243 raised to the 1/5 power. Negative 243 raised to the 1/5 power. So notice there's a negative there, so always be careful with the negative. Just like you did here, there's a negative, so you got to remember it's inside the parentheses, so that's your base. Here, there's no parentheses here, so you gotta think about what I'm doing here. So I'm taking this paper and covering up the negative. So the only thing that's being raised to the 1/5 powers is 243. So this becomes, see this right here, this becomes the 5th root of 243, but there's a negative out in front, so put the negative back, okay? And then you're asking yourself, what times itself 5 times? What times itself 5 times is 243. So you have access to a calculator, and the way I'm going to do it in the calculator is just to remind you what this means. So this means what times itself 5 times is 243, right? So let's see, 3 to the 5th. Let's see if that works. 3 to the 5th. Yep, there it is. So the answer is 3, because 3 to the 5th is 243. But it's going to be negative 3, correct? Negative 3. Negative 3. So there's the answer. Let's look at F. Suppose in F I had this, 1 divided by 64 to the 1/2 power. So again, I can change it to a radical. So when I change this to a radical, this becomes the square root of 1 divided by 64. And then just like I did this one, we're going to use the quotient rule for radicals. So it'll be the square root of the numerator divided by the square root of the denominator. And the square root of 1 is 1. The square root of 64 is 8. So I get 1/8. Okay? All right, so that was number 4. So it's not that difficult, just knowing that how to go from a rational exponent to a radical. See that denominator is your index. The denominator is your index. Okay? All right. So let's look at this one. Okay, so the directions here says use radical notation to write each expression and then simplify if possible. So if I look at at this one, so let's say this is letter A, and I have x to the 1/7 power. So x to the 1/7 power means as a radical, so you see I need to rewrite this as a radical, use radical notation. So the denominator is your index, so it'll be the 7th root of x, and I cannot simplify the 7th root of x. So as remember in a previous lesson, the exponent here is less than the index. So you're done. That's all you can do. Okay, so in letter B, we have, let's say in letter B, we have this. We have um, 8 times, that's an 8, times x to the 1/6. 8 times x to the 1/6. Okay, now be careful here. So I want you to remember what this means. This means 8 times, and then x is being raised to the 1/6. All right, so if you need to cover up, if you need to cover up the 8, then you go ahead and you cover up the 8. So I can rewrite this part here, as the 6th root of x, but that's being multiplied by 8. So the answer is 8 times the 6th root of x, and I cannot simplify the 6th root of x because the exponent of x is less than the index. All right, so let's look at C. So in C, let's suppose we had, let's do a simple one. Let's say we had 16 times x to the 4th power raised to the 1/2 power. All right, so don't let that confuse you. Don't let that throw you off. So, so the way to do that is first of all, let's change this to a radical. Let's change it to the radical. So the rational exponent means, see the index, the denominator is 2, so that'll be your index, it'll be the square root. So it'll be the square root of 16 x to the 4th. And you learned how to deal with that in a previous lesson. So 16, the square root of 16 x to the 4th means the square root of 16, the product rule for radicals, times the square root of x to the 4th. The square root of 16 we know is 4, right? And note, remember the exponent is 4, the index is 2. 4 divided by 2 is 2. So remember what that means. That means what times itself twice is x to the 4th. So 4 divided by 2 is 2. So you get x squared. So that part you did in a previous lesson. So if you need to go back and review that, please go back and review that. So that's the answer for that one. So let's do another one like this. So in D, let's suppose we had 25 x to the 10th power raised to the 1/2. So remember what that means. That exponent 1/2 means in terms of a radical, that will be the square root. So the index is 2. So it'll be the square root of 25 x to the 10th. And from a previous from a previous lesson, a lesson you had a few, maybe last week or so, I can rewrite this as the square root of 25 times the square root of x to the 10th. And then the square root of 25 is 5. And since 10 is divisible by 2, the square root of x to the 10th is going to be x to the 5th. So what times itself twice is x to the 10th. So it's x to the 5th, because 10 divided by 2 is 5. And so that's the answer you would put there. Okay, so let's look at this one. So in this one we have 81 x to the 12th power, and that's being raised to the 1/4 power. So this rational exponent on the outside, I'm going to change to a radical. And so this becomes the 4th root. See, the denominator becomes the index. The 4th root of 81 x to the 12th. And then using the product rule for radicals, I can rewrite this as the 4th root of 81 times the 4th root of x to the 12th. And I know that the 4th root of 81 is 3, right? Because 3 raised to the 4th is 81. Okay, so that's 3. And this one's an easy one because 12 is divisible by 4, so 12 divided by 4 is 3. So remember what this means. This means what times itself 4 times is x to the, that's 12, x to the 12th power. So the answer is 3, x cubed. So x cubed times x cubed times x cubed times x cubed. Once you see this, x cubed times x cubed times x cubed is x to the 12th. So the answer is x cubed. So that's that one. All right, and let's do one more, and this is going to be F. And so in F, let's say we had, and let's do this one. Let's say we had 9x to the 6th power divided by y to the 8th power. And let's say that's to the 1/2. And so remember the outer exponent's a rational expression, so I can rewrite this as a radical. So the index is going to be the denominator, which is 2. So it'll be the square root of 9x to the 6th divided by y to the 8th. And so then this becomes so there are two rules you're going to use here. You're going to use the product rule for radicals, and we're also going to use the quotient rule for radicals. And so this is going to be the square root of 9x to the 6th divided by the square root of y to the 8th, right? And then the numerator, that's the square root of 9 times the square root of x to the 6th divided by the square root of y to the 8th. Okay, so now I'm going to simplify each little part. The square root of 9 is 3. The square root of x to the 6th, 6 divided by 2 is 3. So that'll be x cubed. Makes sense because x cubed times x cubed is x to the 6th. And then over here, there'll be y, 8 divided by 2 is 4. So y to the 4th. And so that's the answer. Okay? Okay, so in letter G, you have -1 raised to the 1/5. Now, that 1 throws people off also. It confuses people. They think that the base cannot be a 1. The base can be a 1. Now, I want you to notice, though, you see there's a negative here, but it's not inside parentheses. So remember, that means that the only the base is being raised to the 1/5 power, so the only thing that's being raised to 1/5 power is 1. So I'm going to rewrite this as this right here, as the 5th root of 1, but there's a negative out in front. And so now we know that the 5th root of 1, so what times itself 5 times is 1? Well, it's 1, right? The 6th root of 1 is 1. The 8th root of 1 is 1. So if the radicand is just 1, then this simplifies to 1. And so the answer is -1. All right, so that was that one. And okay, so there might be some situations, and let me go ahead and write this as number 6. So there might be some situations where they might ask you to use your calculator. So let me just show you how to do that. So this is number 6, and so number 6 is going to say use the calculator to find. Use the calculator to find. And oops, sorry. So use the calculator to find, and then let's look at letter A. So letter A, let's suppose we have 47 to the 1/7 power. All right, so 47 to 1/7 power. Okay, so now there are a couple of ways you can do this. So since we're dealing with a lesson that talks about changing this to a radical, let's go ahead and do that. So this is the 7th root to 47, right? And then we're going to go ahead and round to the nearest hundredth. So round to nearest hundredth. Okay, so we're going to round to nearest hundredth. All right, so remember how to put this in your calculator. You had this in a previous lesson. So remember you're going to put your index first. You're going to say 7. It's 7 for your index. And then the function you're going to use, you see this right above this looks like an arrow right here. So this right here, you're going to click second to get to it. So you're going to say second, then this right here, and so gives you this. So that x is the index you got to put first, so that's 7. And then you're going to put 49, and then press equal, so that's going to be the 7th root of 49. And then to the nearest hundredth, remember, this is the 10th place, so 7 is the 10th place, 4 is the hundredths place, so that's where you round off, because this says nearest hundredth. But you have to look at the thousandths place. So if that's 5 or larger, then you got to add 1 to the hundredths place. So since that's 3, it's going to stay 1.74. So this is going to be approximately equal to 1.74. All right, and then letter B, suppose we had 8 to the 1/2. So using a calculator, so remember this means the square root of 8. And so there's a square root button on your calculator. Now, you may say, well, could I still use this idea here? Yeah, you can. You can put 2. So 2 for square root, then say second, and then this button again. So it'll be the square root of, and then 8, and you get to the nearest hundredth now, nearest hundredth. So 8's in the 10th place, 2 is in the hundredths place. The thousandths place is 5 or greater. See, it's an 8, so this 2 becomes 3. So this becomes 2.83, approximately equal to 2.83. Now, if you want to use your square root button, you could have done that as well. So let me remind you where your square root button is. So you see right here, so you said x squared, so your square root button's here. So you're going to press second square root, see square root, then put 8 in there. You don't have to close the parentheses, and then you get 2.83, okay? All right, so that's going to be the end of this lesson. And remember, this lesson talked about um, the meaning of um, when you have a base raised to the rational exponent 1 divided by n, and so that's where you had to change it to a radical.